And our next panel discussion focuses on a topic at the heart of energy transition, the resilience and operational security of the grid. Panelists will examine how infrastructure upgrades and smart technologies can help address today's challenges in system planning and operation, and where cooperation among TSOs, DSOs, and new market actors is essential. So please welcome our panelists. Davor, Bajs, electricity infrastructure expert at Energy Community in Vienna. Good morning and welcome. Joining us now is Jurij, advisor to the board at Elektro, Ljubljana, the biggest Slovenian distribution utility. Mindaugas Ivanavičius, head of synchronization program implementation center at LITGRID, Lithuania's electricity transmission system operator. Ona Kostinaitė-Grinkevičienė, head of sector for SIF, co-founded electricity and smart grids project at CINEA, European Commission. Layla Sawyer, Secretary General of Curk, the voice of innovative grid technology companies in Europe. Welcome. We have Zoltán Tihanyi, Deputy CEO for International Affairs at MAVIR, the Hungarian TSO. It's a great panel. Hope everybody feels okay. Just one kind request that I have before I give the floor to our moderator. Please talk directly into the microphones. We in this area can hear you, but we have a live stream as well. And if you're not speaking directly to the microphone, people who are watching us online cannot clearly understand and hear you. Okay, agreed on that. Moderating this session is McGranaghan, a fellow at the Electric Power Research Institute. With his experience bridging research and practice, Mark is the perfect guide for today's discussion. Good morning, Mark.
Good morning. Thank you very much. Good morning, panel. We have a big panel here in a short time, so we're going to have quick questions. We're going to try to focus on the topics of resilience and security of supply, especially with respect to the role of smart grid technologies. It's a topic that's become more complicated as the penetration of renewables has become greater. Much of that being distributed, as we just heard, about the greatly increasing role of rooftop PV and distributed wind connected to the DSO, and being able to integrate that and maintain the security of both the transmission and distribution entire energy system. The Iberian Peninsula blackout has taught us that it can be very complicated in terms of power flows and voltage management with this high level of penetration. And things like climate change, cybersecurity, and even physical security have to be taken into account, and smart grid technologies can have a role in all of those areas. We have a project at EPRI looking at the role of grid enhancing technologies, dynamic line ratings, advanced conductors, power flow controllers, and even optimizing the topology of the grid as tools to provide flexibility and support the security of the grid. And as we heard in the opening session, obviously the role of artificial intelligence and getting a handle on how much energy storage we need and how to manage that are going to be critical topics as well. So I think the perspectives that we'll get from this panel should be very interesting, given the complicated nature of the challenge right now. The way I'd like to go through this is to get the perspectives of the TSOs and DSOs represented here first. Then we'll come back to the technology providers and kind of the commission role in all this. So I'm going to start with Zoltán. Okay. As we learned from the blackout in the Iberian Peninsula, the increasing penetration of renewables can make things very complicated, voltage control problems, elaborate power flows around Europe that can result in oscillations that we have to deal with. Can you give me a perspective from Hungary on how this is impacting your decisions and thoughts around smart grid technologies, flexibility, and maybe comment also on how this is changing your thinking about the need for energy storage?
Thank you for the question. It's quite complex and maybe it's strange from my side as a transmission grid operator, but we are also proud of being system operators, I mean, including the market operation, parts of it at least. So this means that it's a very complex cooperation among many stakeholders to provide and to guarantee security of supply in electricity in this case. And this requires this cooperation and the change in this stakeholder group, both in numbers, millions should be active very soon or are active already, active participants in this game already. So the numbers are huge. And on the other hand, the technologies are changing. The transition brings it with itself automatically. So we have to adjust our operations, our manners to that. And the challenges we have in front of us, we cannot manage with the old manner, with the same old tools. So we need new solutions, need new tools, need new equipment, need new ways to cooperate. And this is the role of innovation and the smart technologies. Of course, deeper we will hear a lot today later on technologies, exact technologies. But the role of these technologies is to give an answer to the new challenges. And that is crucial. Without that, we are not able to keep the system alive. And unfortunately, we have already examples for that. So the time cycles we have to manage are shorter and shorter. The volume of data we have to assess, evaluate, use to make decisions in very short time is extremely huge. So without new technologies, new big data, new artificial intelligence based solutions, we are toothless. So that is the new situation, and of course it needs cooperation among many other participants, not only the grid operators, but all the participants of the system as such. And as we say in the ENTSO-E, in the European Association, we are building, and that was a very good message from the previous panel, we must be forward-looking. So what is the vision? We are building system of systems, and that's really true. So not only the electricity, not the gas system, or speaking about storage, and a special type of possible storage in the future is hydrogen, for example. So all these systems must cooperate, and we have to be able to manage them. So I think this is, in broad words, the picture now and the challenges we are facing.
Very good. I think we'll go to Slovenia and Jurij for the next perspective, and I'm particularly interested in how learning from the Spain blackout, controlling and managing the distributed resources connected to the distribution system and the cooperation required between the TSO and DSO, or if they're the same entity, maybe cooperation is easier or maybe not. What are you thinking in terms of approaches and technologies to manage these resources and maintain the security of supply with the wide range of inverters and systems that are out there?
Yes, definitely. It's quite a complex thing. But on the other side, it is definitely that in distribution grid, we will in the future need to approach in more active control actively control the grid itself and flexible resources connected. Here I mean also renewables, which are normally driven by the sun in Slovenia, but at least control of it will be necessary, because nowadays, it's for the May the 1st, it was the total delivery from transmission grid to the distribution grids was 30 megawatts in Slovenia. And the peak delivery is close to 2000. So this is happening in the grid, and without active control in distribution grid, this will be impossible. On the other side, we know, yes, smart solutions, smart, everything is smart, but at the end we can have a big brain, really very smart, but to do something we need hands, fingers, and so on. And here we are short so far in distribution, because even we need to, for practically every investment, we need to prove that it is smart, or that if we want to pull the cable, we practically need to prove that this is really, it cannot be done smart. And this is a little bit now it went over the reasonable view. And in this perspective, we need to buy remotely controlled switches, which are not really smart, but they are fingers doing things that the brain think. And yeah, here we need to do more. And this we need somehow to focus more on that, because there are so many nice applications and programs and software developed through H2020 programs, but at the end we need the switches and communication gateways and LTE meters and so on to really fill that brain with the data and to execute the commands from there. And one MotoGP driver said a few months ago, it is easy to be ambitious, but it's difficult to perform. So we need to know more about functionality that we want, and not only talking about millions and billions of investment. First, to know what we need, which functionalities are needed. This is what I'm missing. This is my perspective.
Are there any new initiatives related to energy storage at the distribution level that would support this wide range and power flow interaction with the TSO?
Well, so far, of course, for larger storages, it is obligation that they are able to receive the commands, but we will also soon probably have more and more pressure with the smaller units, as rooftop solar plants now equipped additionally with the storages of 5 to 10 kilowatts. And so far we are trying to persuade also through some pilot projects that they will also be obliged, not that this is a question of the market, but obliged to follow certain rules and commands from this DSO, because it is in the transmission grid, it's okay because you can transmit, it is meshed network, and structure of distribution is radial. So to solve a certain voltage problem in a certain feeder, there are maybe 2 or 3 resources that can be flexible, and they can put on, if this is a question of the market, they can put on the price, whatever.
Yeah. It's tricky at the DSO level in terms of how to use energy storage on the distribution system. You can't own it. In Ireland, ESB is going out for bid on services from distribution connected energy storage as part of that flexibility option as a trial. And I was wondering if there was anything similar like that.
Well, not for storage. We were running for 3 years like a pilot, and now it's in regular operation, our flexibility procurement system for solving the problem in the low voltage grid. but it's very difficult because there are not so many customers willing to cooperate. And the other problem is that if we have overloading in the transformers, maybe 300 we have in the grid that are of such case out of 5,000 to 6,000 transformers, but some of them are overloaded only for hour or two or few hours in a year, and it's no point to make any special flexibility procurement there. There are cases that are overloaded for 200 days in a year. Again, you cannot switch off the heating of the heat pumps in the whole village for the whole season. So at the end we come to maybe 20 or 30, and we publish tender every year, but so far there is not much response on it. So we had some when we started like a regular operation, not before when that was subsidized through the pilot and so on.
Interesting. Let's go to Mindaugas and get a perspective from Lithuania. You guys have been through the synchronization with the Baltic states with the European grid already, and I'm wondering how this integration supports the security of supply, and if there's any additional issues and challenges that come up once you're integrated that result in the need for smart grid technologies.
So thank you for the question. So for us in Baltic countries, so it was quite challenging period in the last couple of years as we have been finishing the projects and as well preparing ourselves for the synchronization. So it went so that it was always the stability topic was important for our system control guys who were dealing with the as well while working in the UPS CPS system and as well after the connection to European grid. On the other hand, what we have seen in the last couple of years, we've seen many of the incidents in the Baltic Sea. The electricity cables, telecommunication cables, as well gas pipeline were damaged and affected. So it was the clear signal for us as well to work a lot on the resilience as a additional topic to the system security, as well to ensure that our system is secure and we can operate in any moment. So what we are doing now, and we are quite ready with our plans together with our partners in Baltic countries, in Estonia and Latvia, and as well with Poland, considering how we should improve the resilience in our grid. So we have measures ready, implementing a lot for those resilience as a physical security topic. On the other hand, always those smart things are the daily business, which is as well executed, but you need to protect those smart, fragile elements to be ready to operate always.
Is there particular smart grid technologies that are being applied for physical security purposes? Or is it mainly sensors and awareness of what's happening, or are there other approaches? Yes, there are. On the other hand, those smart things, what we should as a VR system operators, we should think that as well we have smart systems which we can use as well as for second benefit. So something is used for operation of a technology. On the other hand, it could be used as some kind of a security systems. So the same topic, one example could be video surveillance system. On one hand as well, you can use the smart technologies like to have simple way to have people who are surveilling if you see on the substation something happening, or use the artificial intelligence to screen many of the substations and to have the signals over there. Other example could be the various type of distributed acoustic systems, which are typically used for technology purpose. On the other hand, it could be converted to the security system just to let operators to get the signals before something is happening in the grid. So there are as well other aspects. So we should consider them. Yeah, very good. Let's go to Davor and energy community countries, and maybe you could give us some of your thoughts on the main challenges for operational security in the energy community countries and potential role of smart grid projects there.
Thank you for the question. So I'm representing 9 countries which are not in the EU but wishing to join the EU, 6 Western Balkan 6 countries, and 3 Eastern Partnership countries, Ukraine, Moldova, Georgia. And the territory of Balkan, Bosnia and Herzegovina, Serbia, Montenegro, 2 North Macedonia, Albania, and Kosovo. So pretty much operational challenges are similar as in Europe, but maybe not at such a large scale because the integration of renewables is not so intense like in the EU. That's something that we still expect to come. But anyway, I would say there are 4 or 5 operational challenges, not to go into them deeply, from aging to large transits due to, for example, large solar production in Greece, lack of coordination. So this coordination between countries, these are small countries, small TSOs, they cooperate, but this level of cooperation should be much higher. A lack of capacity, coordinated capacity calculations. So we have still bilaterally determined NTC values, which are quite low. Then on the other side, we have Bulgaria, Greece, and Romania with the coordinated capacity calculations. And then we get into situations when commercial flows are high on the east through Bulgaria to Romania, but physical flows go to Albania and Montenegro. That's the reason why Montenegro occasionally experience very large transits through the grid. Actually, we had a large blackout last year, and we had in North Macedonia one this year, which was quite, I would say, bizarre. I never heard about the blackout during minimum system load, not only daily, but probably monthly or even annually. It happened on 18th of May. And that's the main issue that I wanted to discuss because it's somehow related with potential smart grid project in the region. And these are high voltages. So the whole region practically suffers from high voltages. The problem spread in the past from Croatia, Slovenia, Bosnia and Herzegovina. Now it happens everywhere. Southern Serbia, North Macedonia, Kosovo, Albania, Montenegro. And actually what happened in North Macedonia, they had high voltages in 5 in the morning on Sunday morning. So that's probably annual minimum load. And practically all transformers 400 to 110 tripped off due to protection of the high voltage, over voltage protection. And they had 2 hours of blackout, which is really quite unexpected. And that's the reason why I wanted to put a reference on the smart grid, synchrogrid project here between Croatia and Slovenia, which successfully, if not solved, but much improved the issues of voltages in these 2 countries. So we also wanted to suggest our countries, energy community countries, to apply something similar. And that's exactly when this lack of coordination came into place. They were not so interested. So every country now tries to solve it by themselves, which is less efficient, which is longer, which puts a risk not only to this specific country, but to the region in general because of these high voltages. And pretty much we would like to learn from the EU experience and apply it in the energy community countries.
Are you also looking at any power flow controller type technologies, power electronic technologies to support the voltage management separate from interconnection and integration approaches?
No, at the moment TSOs at the Western Balkan 6 area, they consider shunt reactors not so sophisticated solutions regarding controllers and such, mainly because of the cost, of course.
Yeah. Very interesting. Let's go to Layla and get a perspective from the technology providers and where do you see investment priorities related to these technologies to support system security needs, and are we starting to see an increased deployment of the smart grid technologies as part of the solutions?
Thanks for that question, Mark. So, so I think from the technology provider perspective, there's a few things. So listening to all the TSOs, I feel, and DSOs, I feel there's kind of an understanding that yes, we need to get smarter. Good that we are all aligned on that. Of course, we do see a lot more uncertainty going into the networks with more distributed resources and much more dependent on the weather. So from our perspective, where innovative grid technologies can really support the operational security of the system operators, it's giving the system operator more tools, more levers to be able to handle uncertainty and uncertain situations. We talked about the Iberian blackout, but there have been also in Ireland, as I'm sure you are well aware, the storms that left people without power in the US, but also increasingly in Europe, wildfires and unseasonably hot weather, more unforeseen situations, and unfortunately this is probably not going to get less. So where we see that really the innovative grid technologies can help, as I mentioned, giving the system operator more levers. So this can be through dynamic line rating, looking at what the actual conditions are on the grid, and then making your decisions based on a more real-time understanding of what is going on the line. And then there's power flow control, which you already mentioned, then being able to reroute it to places where it's less congested, topology optimization, but also a better measurement of the real-time inertia on the grids and be able to play into that, and all around give the system operators more flexibility in how they can respond to these uncertain events. So you asked about investments. So looking at investments, we do see this taking off, not as fast as we would like. And we see it going faster outside of Europe than inside of Europe. And I think there is a world of gain to be had by exchanging more between the system operators. You have certain system operators that have a lot of experience with the DLR or a lot of experience with advanced power flow control. So how can we go faster and not all do the same learnings, but to go faster, to learn from each other?
Thanks. That's a good segue for Ona in terms of going faster and setting priorities at the European level and at the Commission level for best ways to accelerate the adoption and deployment of these smart grid technologies where they make economic sense, and maybe I think through awareness and information sharing related to projects of common interest is a good approach. But what do you see as the priorities at the Commission level?
Thanks a lot, and it's good to be in Ljubljana and see so many familiar faces. I am sorry, Mark, I have to hijack a couple of seconds because it's not common to correct the hierarchy, but I need to get some numbers straight. So before I reply, so you heard before some numbers on connecting facility, and I want to make sure that we are on the same page. So since 2014, when Connecting Europe facility started working and offering the possibility for many promoters to invest into the grid stability and resilience, up until now, we spent around 8 billion already. So that's the number I got from my team, and I trust them. And we are talking about around 220 projects which are already implemented across Europe, some of them even beyond, if they have a cross-border dimension. Like, personally, I have a portfolio of more than 5 billion, and I and my team are in charge of electricity and smart grids electricity. So we already put a lot, but of course I agree that we didn't put enough. And I think the executive panel was very vocal on that. Second point is that Commission has spoken about the future, more specifically on 16th of July this year, by proposing CEF3 with unprecedented amount suggested. So if I am a very good Eurocrat, I would wash my hands now and say now it's up to the co-legislators, so member states and the European Parliament, to negotiate and stamp the final deal. I can reassure you that CINEA, me, myself, my team are fully ready to ensure the fair and good disbursement of the amount which will be finally negotiated. And I sincerely, personally hope that the amount will be as close as possible to what the Commission proposed, because this is what I see is needed, right? I heard about Montenegro, about aspirations to join. I know that many projects are, brewing. I know that ongoing projects still need to be finalized, right? So this is something where we at CINEA really are working with many of you. Now, I want actually to repeat, I really don't want, but I want a bit to offer you my list of challenges and then speak about one particular point which I heard so far, but I want to make it very prominent. So, aging infrastructure, right? We have various interpretation on numbers, but overall we are talking about 40% of current infrastructure in Europe, which actually needs really to be replaced and made smarter, or brand new, or upgrade. And it's not really, big specificity for TSO or DSO or private promoter. It's something that all our consumers need and I would say deserve to have. Then we have a very clear bottleneck by supply chain disruptions, and I hear very well, Martin, you in executive panel, permitting. Yes, this is something which is at core, and I hope grids package will offer some relief. But when it comes to the actual impact, what we saw, it's implementation in each member state, what matters for permitting. Then integration of intermittent sources, of course, yes, that's something which many of our smart grid projects deal with at DSO level. It's very, very nice to see that sometimes a very smart primary substation in, I would say, in the middle of nowhere, if I can qualify like that, makes a huge difference than having something huge, and colossal. Extreme weather conditions, absolutely right. And that was the first time I heard about tornado in Czechia. And apparently our smart grid project, timely implemented, really stepped in and helped. Cybersecurity incidents, obviously, and very, very present protection of the physical infrastructure. This morning I woke up to the report that the drones were yesterday falling in Poland. Well, not the news I would have expected some years ago, but it's not the first time, right? They were falling in Lithuania. By the way, I was in Lithuania at the time. They were also falling in Latvia next to my precious CEF asset. So I really feel it's very, very real. And this is something where Connecting Europe facility is doing already something. Maybe not enough. We still have call ongoing. So we see, but it's now a thing which we not only need to speak, but we need to act. And I would say pretty fast. And then it comes to the emphasis I want to make is, for me, the keyword is cooperation. Cooperation on many levels. The Minister of Energy for Slovenia today also spoke about partnerships and emphasized the regional cooperation. Sometimes regional is a concept which might not necessarily be cross-border. And I really invite all of you here in the audience today to use this golden opportunity created to us by LS. My big thanks to LS, because you can share, you can talk to each other, you can create these partnerships, and you can really cooperate with each other, you can learn from each other. And Seth here is really to stand by you, with you, and where possible to help you. So I would stop here.
Very good. I think that last note of cooperation is really key in terms of moving these technologies from demonstrations to becoming the way we design and operate the systems, and that's absolutely key. Let's go through the panel and get a quick perspective on what you think are the most important needs related to research and innovation and demonstrations, where we still need help to understand the technologies and how they interact with the grid and what's possible. Where you see the priorities are there to help address security and resilience, considering all the aspects, cyber, physical, extreme weather. Where do we need to work in terms of demonstrations and innovation? And we'll go back through in the same order. So starting with Zoltán, if that's okay.
Yes, of course. I fully agree that cooperation and sharing the gained experience or knowledge is key. So whatever we are developing, usually we come together, so not singular developments are in front of us, but or behind us, but successful common investments and developments. But anyhow, usually they are involving only a few participants. But using the results, showing the results, sharing the experience, that is key to disseminate the gained knowledge. So that is on the one hand very important. And on the other, the challenges we have already mentioned today are growing over one or a few participants, TSOs, DSOs, whoever. So we have much larger challenges, issues every day in the operation, also in the long-term optimization of the system. We are not able to rule, to manage, to run the system alone. That is the reason why the regional methodologies, that the regional cooperation is in the legislation already. Of course, the next step should be very soon the cross-regional, so the extension of this cooperation. But that is the only way, and we have already central stakeholders, central service providers, basically owned by the TSOs in our case, for example, where we are running common processes, using common tools. And this way we can maximize the welfare coming from the optimization. So this is the only way, and on the other hand, this is a must then to cooperate, to work together on the methodologies, on the tools themselves, on the investments. But these are huge investments, unfortunately, and usually these are huge investments and taking time. And on the other side, on the vendor side, it is also a challenge. The transition is quite fast, and we have to find the answers to that very soon. It was said, and I agree, we are lagging behind in terms of preparing our systems for the new way of cooperation. So we are lagging behind. We need common investments, need common developments, And in this respect, the only way is to cooperate and to agree on common priorities, because we have to prioritize. We have limited resources, both in human and in financial way. So we have to work together on that and find the common ways. That's the only way out from this situation now.
Great. Jurij?
Okay. It's simple. In Europe, we need to reinvent how to produce equipment for grid for economically acceptable price. That's all.
And jump right to smart equipment. Make the leap as we bring the manufacturing back.
It's same. We have like European big project digitalization, but we don't have software manufacturers. We don't have hardware manufacturers. We have nothing in Europe. But this is the main goal of Europe.
Good point. Mindaugas?
Yeah, I fully support that production or reducing production in European Union and reducing delivery times is something we really need to tackle. To have this topic in front of us, because it's like for a resilient topic you need, or it's a climate related, or it's some kind of a sabotage acts. You need to recover and repair the facilities very quickly. So you need to be ready, and as well production is one of the key topic here. On the other hand, for adding on top for what we discussed, I think that it's important as well to not much to invent for the physical security. It's more cooperation between the institutions as well, the state defense authorities we have in every country, and as well to share the knowledge between the TSOs and DSOs. So we need to get results quickly. So inventing takes time, and in general the solutions exist in many of the cases. So we just need to take them and use what was not the case for the latest decades in energy sector.
Great. Okay, Davor.
Okay, I will contribute, not to repeat the others. So what we can see in Ukraine, that's unfortunately probably the future which will happen. I don't know, in 10 years or 100 or 500, but it will probably happen. So the main problem are attacks to energy facilities. Okay, if we talk about electrical energy, so they suffered a lot, still manage to operate the network, but in Europe we should also maybe think more about these strategic decisions, how to protect our networks and the infrastructure. Okay, so we are all in the Green Deal, we will construct very large offshore power plants, but these are very easy to be attacked as well. And we should think more about security, not to, dream that the future will be so nice as before 2022.
Yeah, does that mean more distributed?
I don't know what does it mean, so I'm not the cleverest guy in the world, but yeah, this is also a possibility.
Okay, very good. Layla, what's the priorities that you're seeing in terms of how research and innovation and demonstration projects can help accelerate the deployment?
So I would first say that our biggest problem is not R&I, but scaling up what we have already developed. So that as a given. But then if we do, to answer your question, looking at R&I, I think it's important, to focus, we've talked also a lot about the smart solutions, but also the hardware side needs innovations. We can develop where some of our members are working on cables based on superconductors. These are technologies that can make a huge difference for Europe in terms of building a super grid, a meshed grid. Then I would say that on the more software side or enhancing side, how these technologies can combine together to create a kind of a multiplying effect If you take one technology, it can deliver a certain amount of benefit, but if you take a group of technologies in combination, can these deliver more than the actual sum of their parts? I think there is a lot of work still to be done there on the R&I side.
Yeah, that's a really good point. Ona, to finish it up, maybe, and your list of priorities was right on target. Maybe you could give us some thoughts on where the AI strategic plan fits into this equation and how that's going to be integrated with projects in general.
Well,
Sorry
actually,
to hit you with that broadside.
well, somehow Amazon hasn't delivered the crystal ball before this meeting, so I can't predict much on that. What I know that there is a very clear determination, including in this room, but even beyond, to go and deliver. So not to sleep on decades, which were mentioned by some of the panelists, but really do things. I see that also in the field when I go and see and talk to people. So I actually am more optimistic than some of my panelists on that. I still very European in the sense that we can. And I think what we really always kind of need to keep in mind that technology is to help us, not really to be a servant of technology, but really to have it to service us. And when we are talking about energy sector, we all work for the consumers who are ultimately our clients. So as a consumer, I really want to have technology. I really want to have electricity, hopefully, as well at home. But at the same time, I want this innovation factor, which many of companies present here, they are living for that. And later today, I think we will hear many good cases to support basically this claim. And I really built my trust on that.
Great. It's a good positive note to finish. Let's call it there in interest of keeping us on schedule. And I want to thank all the panelists for great contributions. Thank you very much.